Hi everyone and welcome to this new video in which I continue my Windows Privilege Escalation series. Now this video is going to be very interesting because we will introduce the concept of antivirus in the context of Windows, and we will talk specifically about a feature called AMSI, which is used to connect a program with the antivirus essentially, and we will show how we can bypass this feature. AMSI, for example, comes into play when we launch a PowerShell process. So consider here, I have this PowerShell shell here, and here I have the real-time protection activated. Now, if in this shell I execute malicious code that is recognized by the antivirus that is running, which in this case is the default Microsoft Defender, now the shell is not gonna allow me to execute such code. For example, to see this in action, we can simply write invoke mimikatz. Without even having the command actually available, we can just write it and notice that if we execute it, it's gonna say essentially, look, the script contains malicious content and has been blocked by your antivirus software. Now, when we see something like this, what is actually happening is that AMSI is the interface between the PowerShell process, which we are running, and the antivirus. So antivirus, which in this case is Microsoft Defender. So the idea is that AMSI is this interface, is this middleman. So when we write something, this thing is scanned by AMSI. So AMSI comes into play and it says, okay, we need to scan this content. To actually perform the scan, the antivirus is used. So for example, in this case is Microsoft Defender. Microsoft Defender recognizes that something is malicious and tells AMSI to tell PowerShell, look, you cannot execute this program, I'm gonna block it because it is malicious. So that's the idea of AMSI. In this video, we're gonna go into a little bit of depth into how it all works and how we can bypass it. Now, there are many different ways of bypassing AMSI, and they are patched by Microsoft, so they change every time, but the general strategies are kind of the same, essentially. So I'm gonna show two specific methods, and I'm gonna put a link to the references where I've taken them, so feel free to experiment on your own. So that's it. I hope this video is gonna be enjoyable. This is content that is not strictly needed for basic certification like the OSCP. You will not be required to bypass antivirus. However, I felt it was good to put it at the end of the course because it is a little bit more complex topic. It would deserve a lot more effort and time, of course, dedicated to it. I mean, it could deserve many other courses on the antivirus evasion, EDR evasion, AMSI bypass, and things of the sort. Today we will introduce the main idea of the subject of all these concepts and all these areas of research, and we will show practical AMSI bypass, true practical AMSI bypass. So as always, I hope the video is interesting. If it is, leave some feedback, subscribe to the channel, share this video and this channel with like-minded people to help me grow, and enjoy the video. So let's get straight into the discussion by analyzing what is exactly an antivirus. So an antivirus is a software program designed to detect, prevent, and remove malicious software, which is also known as malware. So the idea is that we have normal software and we have malicious software. And this is pretty intuitive. Malicious software has malicious intentions with respect to the user of the software. So when someone installs a malware, the malware acts against the user that is installing the software because it is malicious software. Now, this means that how do they recognize what is malicious and what is not malicious? Because this is the big idea. It's like, given a piece of software, let's say that this is a piece of code. How can we understand if it is good or if it is bad? How can we understand if it is malicious or if it is just normal? Maybe a little bit weird, a little bit unconventional, but ultimately not malicious. Now, to do this differentiation, different techniques can be used. And of course, these are like big areas of research that are being expanded every day, essentially. So the idea is that we start with a simple signature-based detection. So the idea is that you have so-called malware signatures. Now, what is exactly a signature can depend on how nuanced you want to be, essentially. But for example, a very simple signature is literally the hash of the executable. So you take the executable file, which is just a bunch of bytes, therefore just a bunch of data, and you compute an hash on it. For example, you could compute the SHA-1 of the executable, and you get a certain fingerprint. Now, if you find a program with the same SHA-1, then you can be sure that most likely it's going to be the same program and therefore it's going to be malicious. So this is one of the simplest way to do detection. Why? Because the problem with hash functions is that by construction they are very sensitive to the input. And this means specifically that if I take a malicious executable and then I literally change one byte in the file, just one, maybe a byte that has to do with some text, so ultimately I'm not really changing the function of the malware, I'm just literally changing one byte of the file, and I compute the same hash, I'm gonna get a totally different signature, a totally different digest. This means that signature-based detection can be easily bypassed if we compute simple signatures, essentially. And so this is the first thing. Of course, other kind of activities are, for example, strings that are found in the binary. So patterns of strings found in the binary, pattern of bytes found in the binary, they can also act as a signature, essentially. So anytime we have a database with signatures for malware, and then when we want to scan a program, we extract the fingerprints of this program that we want to analyze, and we compare it with the database of malicious fingerprints, and if we have a match, we consider it malware, or we consider it not malware if we don't have a match. So that's the idea. Now, how can we extract these signatures? To extract the signatures, there are a lot of techniques, but these techniques can be mainly done in three categories, which is static analysis, dynamic analysis, and machine learning analysis. So the static analysis, essentially, the idea is that you want to understand the malware as a static file. So the static bytes of the malware, which means that, for example, if it is an executable, from the executable, you can get a lot of information, like, for example, the DLL that is going to load, the main entry point of the function, the code of the executable, the data present there, a bunch of attribute data, if it is signed or not. Like, all this kind of stuff can be analyzed through static analysis. For example, if you use Ghidra as a reverse engineering tool, and the idea of using Ghidra, of course, is to produce the decompiled version of the binary, so where we can see the source code of the binary. So sometimes what researchers do, a lot of times what researchers do is, instead of executing the malware, which could be dangerous, they start by understanding its static structure. So the static code that is loaded at startup when the program executes. Now, the problem with static analysis is that sometimes it's really hard to reverse engineering the malware because there are a lot of techniques to hide the actual program you want to execute. And for example, a class of tools that is used with malwares are called packers. So the idea of packers is that packers are just executable which contain other executable within themselves. So the idea is that when you first execute the executable, so when you first launch the program, you are actually launching the packer. The objective of the packer is to actually bootstrap the real program that you want to execute, which in this case would be the real malware. So when you are doing static analysis, maybe you are just analyzing the code of the packer, which obfuscates and encrypts sometimes the actual code that is going to run when you execute the binary. This means that extracting information, meaningful and useful information from the malware using just static analysis can be very hard, challenging and time consuming. So what's the next idea? The next idea is to create a lab environment in which you can test out the actual execution of the malware. So, of course, this can be very dangerous because you are executing a malware, so you're executing malicious software. So if you're not careful, if you don't take extra care in protecting yourself through the usage of sandbox environment, so environment that do not leak out information so that the malware within cannot get data outside, this technique allows researchers to understand what the malware is doing. For example, what kind of APIs is the malware using? What kind of system call is the malware calling with respect to the kernel interaction? These kind of questions can be answered through dynamic analysis. And through dynamic analysis, we can also understand how the malware interacts with the file system and with outside servers, so through network protocols. So that's another area of analysis. So we have static analysis. When the malware is not executing, we just execute the bytes of the raw program. We have dynamic analysis, so we are executing the process And then we have machine learning. Now, machine learning, the idea is to use statistical patterns to understand, it's sort of like a fingerprint that is a little bit more probabilistic than a simple hash function, than simple string pattern matching. So with machine learning, the analysis can be more nuanced, more complex. And so with machine learning, the analysis becomes more probabilistic. So the idea is to extract a sort of like statistical distribution of malware, like typically with this malware, how we can characterize it with a statistical distribution, and then when you have a real program and you want to see if it is a malware or if it is not, you do some statistical test to extract, to sample out data, and then you confront the data you sampled with the expected malicious distribution. If the data is too far away from the expected malicious distribution, then you can assume it's not malicious. But of course, I just summarized very, very rapidly. These are very complex area of research, which are all, of course, interesting. Now, in the system, we don't have just antivirus. We also have other technologies which are related, for example, network firewalls or web application firewalls. So the idea is that these tools are specialized for network packet data. So while an antivirus typically deals with files, with process, with things that happen dynamically on the processor, network firewalls are specialized with network packets. So they understand very much the data of a network packet, and web application firewalls even more with respect to the typical traffic that goes on in web application. So HTTP traffic, so TLS traffic, so WebSocket traffic, QUIC, like all the kind of protocols that are used in the web communication. Web application firewalls can analyze such protocol to understand if there are malicious payloads and things of the sort. Then, if we have a big business with a lot of workstations and servers spread throughout a region, and we want to analyze the security of each endpoint, we have different systems which are a little bit more sophisticated, such as intrusion detection and prevention systems and endpoint detection and response. And these endpoints typically would be, for example, the laptops of your employees or specific servers that are supposed to be interacted with outside people. So like sometimes these kind of endpoints are also in the client machines that are used by people, by the consumer of your service, like if you want to extract money from the bank and you go to a POS point, in that POS point, if software runs, maybe there's also an endpoint detection and response, while IDPs tend to be more inside networks. So like protected internal network areas where there is a concept of there is an outside zone, there's an inside zone, and you want to make sure that no one is getting inside. So essentially that's the idea. Now, what about Windows? So this is very, very general. What about Windows? Of course, in Windows, there are a lot of tools and systems and features that allow to protect the system. So we start with the Windows Defender Antivirus, which is the default antivirus present in Windows, which provides real-time protection against viruses, malware, and spyware. So I would say in general, malicious software. Then we have a firewall for network protection. We have the Windows Hello for encrypting passwords. We have the BitLocker for encrypting the disk after we turn off the PC, which is really important because let's say that we lose our work PC when like it gets stolen, but we did not encrypt the data, then anyone can simply take the hard drive and read all our unencrypted data. So if we want to avoid this situation, we're gonna encrypt them. We must actually encrypt the data. It's really important, especially when you deal with work laptops with data that is not only yours, but of the company you work for, of the clients of that company and things of the sort. You want to encrypt everything so that even in the worst case where you lose your laptop and you lose access to the data, you can be assured that no one else is going to be able to decrypt it. Well, this is not really true because there are techniques that have to do with hardware hacking that can extract the BitLocker key, but they are more sophisticated and it's like you really need to have a sophisticated attacker who knows how to do those sort of attacks. For the average attacker, you are well protected with simple BitLocker. And then we have Secure Boot, which instead is a technology that is executed during startup to make sure that the code that runs is actually the correct one. So it's the original one. Now, among all these different technologies, we find the focus on this video, which is going to be the Windows Antimalware Scan Interface, which is abbreviated as AMSI. So what's the idea here? Well, in 2015, Microsoft introduced this AMSI interface, which is an agnostic security interface that allows application and services to integrate with security products installed on a computer in order to provide security scans. So what's the big idea here? And here I have a little picture that I've took from a presentation that I'm gonna link in the description. So this essentially is the image we want to look at. So this one. So actually let me open with Chromium here. So that's the idea. So what's the idea here? The idea here is that we have a bunch of applications. Thanks to the Win32 API, there are specific functions that are offered by a DLL, which is called AMSI DLL. And these are, for example, AMSI Scan Buffer, AMSI Scan String. So they are interfaces to perform security scans. Then there is an internal layer of Microsoft. And then this internal layer calls the actual provider. So the AV provider layer essentially is the engine that performs the actual antivirus scan. And so the idea is that AMSI is an interface that is agnostic to the specific security product. So you're not dealing with this security product or with this other. You're not dealing with X, you're not dealing with Y, you're not dealing with Z. You're dealing with an agnostic interface, which is the called AMSI Scan Buffer, AMSI Scan String. But then on your machine, depending on the various providers that you have, you could scan the same buffer or the same string with, for example, 3 different providers to have 3 different results, and then you can compare them and things of the sort. So that's the idea. For example, in this case, this is the Windows Defender service, so the executable of the Windows Defender antivirus, and the idea is that the AMSI layer then interacts through remote procedure called through RPC layer with the actual provider, so with the actual process, with the actual code that has all the antivirus scan logic implemented. So that's the idea. It's just an agnostic way to do security scans. And of course, since it's agnostic, it can be really useful. So that's the idea. Now, what's the data flow of AMSI? So application or services request a scan. The request is then sent to the AMSI provider, which is a security solution installed on the system. If you have no security solution, it's going to be Windows Defender, the default one. The AMSI provider performs the actual scan using its own malware detection algorithm, and this can be the default one, can be for a specific product and things of the sort. And then the results of the scans are returned to the requested application or service in order to allow or block the requested command. And the idea is that AMSI can analyze the following components. PowerShell. So in the PowerShell process, we have this interface, Windows script, JavaScript and Visual Basic Script, Office macros, Excel macros, .NET programs, and using the Windows Management Instrumentation WMI. So that's the idea. So for example, to list out all existing AMSI DLLs, we just do task list /m AMSI with a wildcard. I'm gonna copy it better. And notice what do I get here? I get that here I have the AMSI in both the task list.exe and also the PowerShell.exe. So it means that in the current PowerShell process, I have an AMSI DLL loaded in, and this is going to be used when I want to execute various commands. It's going to scan, essentially. It's going to scan the command to see what's going on, if it's malicious or not. And for example, I just open a different PowerShell and notice I have a different PowerShell process and I have a different AMSI DLL. So that's the idea. And to list out all the AMSI providers in my machine, I can use the WMI interface with this command essentially. Just gonna copy it here, and notice here, in this case, it's gonna say Windows Defender, because I just have installed the default protection, which is Windows Defender. So these 2 simple commands. And these, I've also taken them from the reference, which is gonna be this talk, essentially AMSI and Bypass, review of known AMSI bypass techniques and introducing a new one. I'm gonna put a link into the description for those interested in more. Essentially, developers can use AMSI using the following interface. So we have initialization for the AMSI data structure within the process. And notice here we use this AMSI context. So we put a pointer to the AMSI context. We put the address of this structure. then we open a session and then we scan a buffer. So for example, scan buffer per session, these are the AMSI API, this for initialization and this for the actual scan. Notice that the AMSI context is passed throughout all these functions. And so that's the idea regarding AMSI. We have a process such as a PowerShell process. Now, when we use this PowerShell, typically we send a bunch of commands to it, right? We have a bunch of input, and if we want to understand if the command is malicious or not, we call the AMSI interface to scan a string or a buffer of bytes. Then AMSI takes care of communicating with all the different security solutions, XYZ. Each one of them is going to use their proprietary algorithm and their stuff, and they're going to give the result back to AMSI, which is going to give it back to the PowerShell process. So it's a very intuitive thing to have if you think about it. Instead of having that each process has to comply with all the different interfaces of the different security vendors, since these are activities that are most often done in the same way, we provide a common interface. And this is the objective of AMSI, to provide this common and somewhat simple interface, as we can see here. Initialize, open, scan, we get the results. So why then AMSI bypass become interesting? Well, the idea is that if we break the chain at the AMSI level, the content is not even going to go to the antivirus. Therefore, we don't even need to bypass the antivirus itself. We simply don't tell the antivirus to scan that particular string. And of course, the antivirus still can perform on its own different types of scan, but it's just going to be different because it's going to have to activate on its own. It's not going to be PowerShell that automatically tells, look, can you scan this, can you scan that, can you scan that? So the idea is that by bypassing AMSI, we are avoiding to call too much the antivirus. So it's going to give us a little bit of breather time to do whatever we need to do. For example, practical example. So in this case, AMSI is activated. There is real-time protection. So in terms of local protection, everything is activated. And for example, let's say that I'm downloading, so this is the payload to download the reverse shell script, so the invoke PowerShell TCP, right? So I execute this, and what do I expect is that what's going to happen is this string is going to be passed to the AMSI scan, is going to be passed to the Windows Defender, is going to say, look, this is not good, and it's malicious, and therefore I'm going to block it. So in this case, that's exactly what happened. This script contains malicious content and has been blocked by your antivirus software. Because what happens here is that we, the user, provide this string as input to the PowerShell process. Now, the PowerShell process within itself, has the AMSI DLL, which provides different interfaces for performing scan. The AMSI DLL then interacts with Microsoft Defender, and so this is the chain essentially. Now, how can we break this chain? Well, instead of creating a payload that is not recognized by Microsoft Defender, which is another way to do, and if you really want to defend yourself, you must also do that. In this case, we're taking it a little bit easier, because what we're doing is, okay, we start from PowerShell, but we're gonna try to break the interface that connects PowerShell to the AMSI. So we're gonna try to break this specific interface so that the interface is not even gonna communicate with Microsoft Defender. So we want to remove essentially this layer by breaking something at this layer so that PowerShell is going to ask, is this safe or not? But the AMSI is going to be broken essentially, and it's going to allow us to execute the commands, but it's not going to send our stuff to the antivirus, regardless if it's Microsoft Defender or any sort of proprietary antivirus you can think of. So that's the idea. So how do we do it in practice? Well, notice all these functions use the same structure, which is the AMSI context structure. And this structure, it is not documented by Microsoft itself. So the idea is that Microsoft documents the interface, documents that it takes, for example, a pointer to the AMSI context, but it does not document too well the structure itself. So what virus researchers have done and continue to do, essentially, is they understand how these interfaces form, and they try to break it during the process. So essentially, the idea is that in this process, right now, as of right now, the memory of this process is also this structure, the AMSI context structure. And we want to break it. We want to corrupt it in a way that does not make the PowerShell process crash. So we still have our shell, but we break the AMSI process. We break the AMSI function in a way, not the process itself because it's a PowerShell process, but we break the AMSI functionality. So here I show 2 bypass, and for each bypass here I have the references. So these 2, all method to bypass AMSI, this is 2022, and one liner to bypass AMSI, to bypass the AMSI in a PowerShell. So here are some more payloads. Here I'm just going to explain these 2. So the first bypass consists in modifying one field of the system.management.automation.AMSI utils class. Now this class is an internal .NET class within PowerShell that interacts with the AMSI, so with the Antimalware Scan Interface. And the field we're interested in specifically, it is the AMSI context field. So as I was saying, this field is passed around a lot of times. It is found in this class, in the AMSI utils class, and we're gonna modify it. So the code is actually really simple. It's just these 5 different lines of code. Now let's first execute them to see the effect, and then we're gonna explain them. So we start by executing the first one. So actually let me just copy here, so it's gonna be faster. I don't have to switch all the time. So I'm gonna do it line by line so that you see. Of course, you can also automate this in a script clearly, but I'm just gonna do it line by line for now. So here I'm creating a variable fields. I'm creating the AMSI context. I'm creating a pointer to the context. I'm creating an empty buffer, and I'm gonna override that context with the empty buffer. So this is it. You see how quick it was. Now let's try once again to download the invoke PowerShell TCP. And also notice that with this specific command, I am downloading it, but I'm loading it in memory. I'm not saving it on the disk. And this is actually critical because think about it. If you save it on the disk, the antivirus could be awakened by the event of saving things in a disk. So that could be dangerous. However, we are just executing in a current PowerShell context, so it is a little bit harder for the antivirus to recognize it. I mean, typically it would because of AMSI, but now we are trying to break AMSI, so it's not going to wake up thanks to AMSI. So now let's try to do it again. So let's copy this. I'm going to copy it here. Notice now there's no like this is blocked because of malicious things. All is good. And now I'm going to open a reverse shell for 321 to this port. And let's see if we get execution. And notice I have my shell here. I mean, id does not work clearly because this is on Linux, but I can say wmi, I can say wmi priv, I can do, I can go and create in the desktop. I can create echo test into test.txt. Can create a file, test.txt. So here I have it. And in the meantime, the antivirus still didn't wake up, essentially. So that's the idea. Why? Because we have broken AMSI. With these 5 lines of code, we have essentially disabled AMSI for the current PowerShell session. If I close the shell, of course here the connection is lost. If I close the shell, I open it again, the AMSI is going to be restored as new. And so essentially, this thing is not going to work anymore. So I do this. And I am blocked once again by the thing. I do the bypass again. So this, I get the fields. And once again, I do the bypass. So I'm going to get the fields. I'm going to get the AMSI context structure within the field. I'm going to get a pointer to it. I'm going to create this empty buffer. And I'm going to override the pointer with the empty buffer. I've done it again. I'm going to just execute it again. Notice there is no more error. And I can just execute the shell once again. So you would have to do this, of course, for every PowerShell you spawn before doing malicious stuff, because you have to bypass this thing. So the antivirus is still running. However, it's not activated because we have bypassed AMSI. Now let's say that we do bypass AMSI again. So we open a new shell, we bypass the AMSI process. Actually, with the second bypass, I think it's faster. Yes, it's actually much faster. So I'm just gonna do this second bypass. And we're gonna discuss these two, essentially. So let's try to make sure that the bypass actually worked. So notice I have my shell, and here I can just execute it, essentially. So I can just execute it, gonna copy it, and notice here, I have my wmi, I have the commands, I can do stuff on the computer without triggering the antivirus. Now, let's say though that, here I'm gonna close the shell. So here I have back control on the PowerShell. Let's say that instead of loading it in memory, I'm actually saving it on the disk. So the command here would be IWR here, but then I would do out file test.ps1. So I do this, and notice that the antivirus wakes up and it says, look, I found something malicious. So why does this happen? It happens because we have triggered an event in the system which is writing to a file, so the antivirus woke on its own. It was not called by AMSI, it was called by the you wrote to a file event, technically. I mean, you gotta see internally to understand exactly, but that's the general idea, is that we trigger an outside event. It was not triggered within the PowerShell process, it was the interaction between the PowerShell process and the file system. And the antivirus, of course, is made to analyze the files that you are saving because they could be a potential source of malware. So when the data hits the disk, it goes through the antivirus. If you want to make sure that even if you save the file, the antivirus does not recognize that the file is malicious, then you need much more techniques, more thoroughly. You need to essentially pack the malware, you need to obfuscate it, you need to encrypt it, you need to do a lot of techniques which we will not cover in this video. In this video we will cover the AMSI bypass because it is a quick way to get through the antivirus without actually getting through the antivirus. And here the idea that maybe can help intuitively to understand what is going on is that with an AMSI bypass, we are not creating a payload that is not detected by the antivirus. Rather, we are just avoiding the antivirus altogether. So the payload can easily be recognized because we don't obfuscate this payload. However, we are just like being very, very stealthy with respect to let's not wake up the antivirus. And by doing that, we just bypass AMSI. So that's the idea, because AMSI is the mechanism that allows the antivirus to wake up. So that is the bypass itself. So let's explain it now, because as I said, it's actually not that hard. So let's open a new buffer here so we can explain in depth. So what's the idea? Well, the first thing, so the idea is that we're going to use the reflection mechanism of PowerShell. So the reflection feature of PowerShell. And with reflection, we mean when a process is able to inspect its own memory. Because, a process is just memory, and the idea is that process typically handle their data, so a specific region in memory that deals with the program data. However, sometimes through reflection mechanism, through reflection support, a process can see its own functions, can see the code of its own function, and therefore it's sort of like you can think of it as it can modify itself in memory. So that's really a cool and powerful feature, and we will use this feature to patch the AMSI structure. So this is why the first code is this ref assembly get type. So we are getting essentially this particular class in the context. So it's called System Management Automation AMSI Utils, and of this class we're getting all the different fields, also those that are non-public. So in a way, through this reflection mechanism, we can avoid the typical mechanism of class-oriented abstractions, which would imply that a non-public method, a non-public field, for example, cannot be accessed outside the class. Well, in this case, through reflection, we're just going to extract all the different fields. So if we just do the first thing, notice this, if we just do this, so let's see the payload here, we just have to take the ref until the end of the AMSI utils. Notice we get essentially the class AMSI utils. Then we get all the fields, right? And we put it into this class fields. So let's open a new shell actually. So let's open a new shell. So we get the fields. And then if I just print out the fields, here I get all the different fields like AMSI lock object, like AMSI init failed, like AMSI session, AMSI context, and all the metadata of the field essentially. So that's the idea. So the second thing the script does is out of all these fields, we are filtering the one that ends with context. So this is very, very important. So what's the idea here? The idea is that we are filtering essentially. So we are doing this. So we are filtering only the field that is called AMSI context. And here, to be more specific, we can say $_name like context, or we can even be like equal AMSI context, like this. It's the same. However, what's the catch here? The catch is that sometimes antivirus software does not allow certain words, certain strings. So for example, if it sees AMSI context, it could simply block the payload it could trigger some alarm, so that would not allow you to actually perform the AMSI bypass. So this is why sometimes you want to be a little bit smarter and work with the string pattern mechanism. So for example, in this case, we want to say, okay, give me the field where the name ends with context and starts with whatever. So if you see all the different fields before, only the AMSI context has this property. So it's an indirect and implicit way of just extracting the AMSI context, which can bypass certain security protection. So very simple protection, but it's also very simple to bypass. So that's the idea. So we're getting this specific field. It's sort of like, you have a class in .NET, in C#, you have a class, and this class has different fields, and we're just extracting one of them, which is called AMSI context, which is the one that is not documented by Microsoft. At this point, we are getting the value of this field, and we are essentially casting this value to a pointer, an integer pointer. So this is, this value. So we do this. So let's do this other because I still haven't executed it. So AMSI context. So this is the field. And then if I just do AMSI context get value, I'm gonna get the pointer value to it. So if I say AMSI context pointer, so let's say context pointer, I get this big number. And if I take, for example, GDB and I print this number into hexadecimal, I'm gonna get this particular value, which is a memory address of the PowerShell process. So this value 0x1b6247 blah 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 is actually an address in the PowerShell process that is executing on the Windows operating system right now. And specifically, it is the address of this particular field of the AMSI util class. So that's the idea. Then here we are setting an empty buffer. So this is really simple, nothing to do with AMSI, it's just an empty regular buffer in 32. And finally, the actual bypass itself is we're gonna copy this empty buffer into the AMSI context pointer. So that's the idea. And this kind of copy is also called as managed to unmanaged memory copy. Because the idea is that we control the empty buffer. This is managed memory. This is memory that we deal with, that our program can deal with. The AMSI context pointer instead is unmanaged memory because technically this is memory of the operating system of the AMSI interface of the AMSI DLL. So technically it should not be us who modifies that memory. We should just be consumer of that memory, and actually we should just use the AMSI service itself. So the idea is that we're going to override that memory to break the AMSI interface. So that's the idea. We do the copy, and that's it. We have bypass AMSI, nothing is broken other than AMSI, so we're good. And now we can do whatever we want. So for example, we can do this, we can load the shell, we can also write invoke Mimikatz. Because the funny thing is that, okay, I don't have the command invoke Mimikatz because I still have to import the Mimikatz module. But antivirus are programmed to just detect the fingerprint invoke Mimikatz. So notice, in the left, I have a shell in which I have bypassed AMSI. In the right, I have a shell in which I still have to do the AMSI bypass. If I write invoke Mimikatz on the right, I'm gonna get, you've been blocked by the antivirus. If I do it on the left, it's just gonna say, look, I don't understand this command, because I still have to load the module, but the antivirus will block it even before. So I would say a good test, if you can make alarm in your system, is just to use this string as a sort of signal to see if you actually bypass AMSI. And so this is the first bypass. As you can see, we're just manipulating simple memory of the process. Very, very simple, few lines of code, and we have our bypass. Of course, this bypass can be also very complex. The second one is also pretty easy though. I mean, at this point, you should have all the knowledge to actually understand it. And actually, I'm gonna leave you to it with this. So I'm not going to explain, I'm going to give you a little bit of time to actually see it. So we do this, first we do this, then we get the fields, then we do this, and then we do this. So how does this second bypass work? Well, sort of like similar, very similar. We still get the AMSI utils class, we still get the fields. It's just that at this time we use the AMSI init failed field. We don't use the context, we use the init failed, and we set it to true. So that's it, we set it to true. Sort of like we put the field to true, and also this is gonna work. As they say, it works on my machine. So gonna do two instructions. So this one, remember, the one on the right, still have to bypass it. So we're gonna do it on the right, gonna do it set true, and let's do invoke Mimikatz. And right now I have the same error on the left because I have bypassed the AMSI mechanism. So now it goes back to say, look, this command is not loaded. and then you would load the invoke mimikatz, and then you would actually use mimikatz. Or if you just want a reverse shell, we can just do a listener here. We can just get our shell on the right. So we're gonna load it in memory, and we're gonna execute it directly in memory. So that's the idea. But of course, we still, ID does not work because I always forget I'm in Windows actually. So I can say UMI. Perfect. So once again, remember, we did not actually bypass the antivirus itself. We bypassed the AMSI mechanism, which connects us to the antivirus. If I put this in the disk, so if I put this in the disk, so for example in disk, okay, no, here I totally fucked up because I copied wrong. So here I should say output file test.ps1. Actually, I don't think output file like this. Out file, I think it's called out file, and boom, we have triggered the antivirus because after all, we still didn't bypass the antivirus itself. We just bypassed AMSI. So essentially, this is it for this video. We show 2 bypass to AMSI. In this video, we roughly introduced the idea of antivirus and of Windows technologies that deal with the protection of data, essentially, and specifically we zoom in on the AMSI, which is the Windows Antimalware Scan Interface, which is an agnostic interface that Windows implements and that connects processes like PowerShell to the various security solution installed in the target system. So the idea is that by bypassing AMSI, we are actually not even caring about bypassing the antivirus itself, we are simply not triggering the antivirus. Although this approach by itself has some limitation, because if we hit the disk, then we still have to bypass the antivirus itself, so we still need to take care into protecting and preparing our payload for hitting the disk on the target. But of course, that would be a whole other topic. I could make an entire series about that, about antivirus bypass. And essentially, this is the idea. So here I leave all the references. There are a lot of methods to bypass AMSI. So especially this link is suggested because look, you just have a lot of different methods, for example. And here you have also like AMSI fail, which generates like a payload that can bypass AMSI, but this can also make the PowerShell crash, so they are not always super reliable. So essentially, that's the idea. Now, I hope the video was fun, was enjoyable. I hope you learned something new. I hope you learned about this AMSI interface and how to bypass, and after all, how easy it is to bypass. Of course, Microsoft sometimes patches these things, so things could change, could get a little bit more complex. It also depends on the version that you're running, essentially. In this case, let's do a quick system info. Let's do a quick system info to understand the version because I don't really remember. So essentially here I have a Windows 10 with build 19045. So essentially that's the idea. Now, I hope the video was fun. I hope it was enjoyable. If it was so, leave some feedback, subscribe to the channel, share this video with like-minded people, and to the next video.